So these next two videos are going to talk about series circuits versus parallel circuits. We're going to start with the series circuit. Now, the cool thing about circuits is that you don't have to have one individual simple circuit for every light fixture in a building. You can actually piggyback them one on the other. Okay, so a series circuit and a parallel circuit, we're looking at circuits with multiple resistors in them. So more than one. Okay? Now, the difference being, I'm going to draw out a series circuit and then I'm going to draw out a parallel circuit on the same page so you can see how they are different. So in the case of this series circuit, I've drawn three different resistors. So what the kind of defining feature of a series circuit is that all of the resistors are in one continuous loop, which means that if one of these resistors breaks, the whole circuit shuts off. So that's a really good way to identify whether a circuit is a series circuit or a parallel circuit. If it is in series and one thing breaks, one resistor, then the rest of it will break. Case in point, Christmas lights. For the longest time, Christmas lights were made in series. And if one little light blew out, the rest of that whole string of lights did not light up. And I can remember as a child having to be the one who had to take every bulb out and put the new bulb in and test. Because we didn't want to have to go and buy new bulbs or new sets of lights. Okay, and my poor dad, we had a house that was this long thing that went like this, and he had Christmas lights over in sections all the way up. You know, those little icicle lights in different sections? And every year, one of those chunks would just burn out. So he'd have a big blank spot. And he would get so angry, and we'd take the lights down, check every one. So the good thing about a series circuit, okay, is that it does let you know that's kind of like an automatic shutdown. If one of the resistors is broken, the circuit does not continue because the loop is broken. Okay? The loop ends up being cut somewhere. It cannot continuously move. But the downside to a series circuit is that every one of these resistors takes a piece of the power pie. Okay? Whereas in a simple circuit, all of that energy was going to that one resistor. Now each of these guys is sharing that voltage. Okay? So if let's say, in theory, let's say you've got your total voltage, okay, which is V total, right? It's your potential difference. In a series circuit, that will be equal to whatever V1 takes, whatever V2 takes, and whatever V3 takes. This being resistor 1, 2, and 3. So they all take a piece of that pie. Okay? So if I was to draw a pie here, it would be divided into 3 even parts. Okay? Everybody, and even, I say. Not necessarily if they're 3 different resistors. Okay? If you've got different level resistors, they're going to take different amounts of that pie. Okay? But you can measure how much voltage is being taken by any of these guys. By one at a time, you will know how much voltage is leaving your power supply. And then what you can do is you can just take your voltmeter and you tack it on and you get a reading. Then you remove it, tack it on here, you get a reading. Then you remove it and you tack it on here and you get a reading. And these 3 readings are your V1, V2, and V3, and they should equal the actual reading coming out of your power supply. Okay? So that is a series circuit. A parallel circuit is different than a series circuit because it is not one continuous loop. There are different choices, you can call them, for the energy there are different pathways for the energy to go. Okay? In this case, we make what we call little branches or nodes. So this is where another wire is going to intersect and it forms like a T. You get two metal wires touching and then one clamped in the middle. Okay? So it's kind of like a fork in the road. Some of the energy, it can choose to go straight and continue on. And some of it will go this way and it will light up this bulb. Okay, or it will do whatever it is. And it will just keep on its merry way and it will go back to the power supply. Okay? The other option is that it keeps going. And if it keeps going, it could keep going this way or it could go back down. And if that's the case, it'll just keep going down and go back to the power supply. Or finally, it could even keep going here and it comes through this guy and then keeps going. So the interesting thing about voltage in a parallel circuit is this. Look at this formula. V total is going to be equal to V1, which is going to be equal to V2, which is going to be equal to V3. They're all going to be the same. It's like everybody is getting a whole pie. No sharing. Okay? And the difference here is that, oh boy, if this guy breaks, nobody cares. That one's not going to light up. All the other ones will. So in a classroom, again, in a classroom, when a light bulb burns out and the rest of them are still lit, that is a sure sign that that is what kind of circuit? Parallel, because if one of them broke, the rest of them would not work. Okay? That is the difference between series circuits and parallel circuits. We are going to be measuring these to prove that in our labs.